Thank you very much, Prof. Henry, for the kind introduction, and thank you very much also to NNI for the opportunity to talk today about behaviours. We study eating behaviours in our group in Singapore, child eating behaviours, but also adult eating behaviours, and the kind of activities and behaviours around meals that promote greater energy intakes. And so we're going to move from malnutrition or undernutrition now to the second talk will be more around the aberrant eating behaviours that promote positive energy balance and weight gain over time. And one of the reasons we're so focused on behaviour is because we believe that we can understand and objectively quantify behaviours in a natural way, and from this gain an understanding of how we can best intervene and change those behaviours through the ways we either interact with children or adults around foods and change the food environment on the plate. So we have heard a lot in the last day or so around the first 1,000 days and the modifiable risk factors that occur in the first 1,000 days. And the reason this is so interesting from our point of view, of course, is because if we can identify risk in the first 1,000 days, we may be able to identify at-risk children who may be more inclined to gain weight over time. And that's important because we want to prevent obesity early in life and reduce the onset to adult obesity. And two of the factors that are identified as being potentially very important in the first 1,000 days are parental body mass index, not only because of the genetic inheritance in relation to risk of obesity, but also because an overweight person has a food environment that promotes that overweight as well. So that, in theory, can also be a phenotypic inheritance. And this is data from our GUSTO cohort in Singapore with Izzadin Aris, where he's highlighted that if you have an overweight mother or an overweight father, your likelihood of being an overweight child is very high, and the transfer of that to adult overweight is also very high. What Izzadin's also done, which I think is very nice, is he's looked at the growth trajectories of children in our cohort and seen the children who are overweight at 4 years of age, for example, and gone back and looked at the occurrence of the risk factors within those children at birth, so within the first 1,000 days. And what you see is that there are differential contributions by certain risk factors, but cumulatively, if you have more risk factors in the first 1,000 days, you're more likely to be overweight by the time you're 4 years of age. In fact, if you have 4 or more risk factors in the first 1,000 days, you're 11 times more likely to be overweight within our cohort than if you have no risk factors at all. So this is incredible because it means that we have an opportunity to identify children at risk and hopefully intervene. But how do you intervene then with regards to the risk factors? Because certain risk factors include things like gestational weight gain or breastfeeding duration or early introduction of solid foods. You can make recommendations around those types of risks, but how do you translate those recommendations into behavioural changes? So one way in which the risk of obesity manifests in terms of translation from early life risk into an overweight or obese child is through what this behavioural susceptibility hypothesis to obesity, which is from the group in London from UCL. And the idea here is that your genetic predisposition to become obese manifests as an increase in your appetitive traits that drive your desire to consume food and make you more predisposed to greater energy intakes from within the food environment. Children with higher appetitive traits consume more energy over time, are in positive energy balance over time, and eventually become overweight or obese. Our group, we're very interested in this little link between appetitive traits that occur and manifest and emerge early in childhood and become stable around meal times, and how these traits manifest as behaviours around how children either select their food or consume their food or consume food in the near environment in general, and also then how these behavioural traits are manifest or moderated by the parental influence. And so for the next half an hour or so, I'll talk about our work in this area, largely around mealtimes, and we've been able to study mealtimes within the GUSTO cohort at 2 time points, at 4.5 and at 6 years of age. And within these meals, we've been able to understand a little bit more in detail around the observed behaviours we can see within children that are driving energy selection up, energy intake acutely up, and then correlate that with changes in body composition over time. So just to introduce the GUSTO cohort itself, since its inception in 2009, GUSTO, the Growing Up in Singapore to Healthier Outcomes cohort, has profiled around 1,200 mother-child pairs from birth and has extensively phenotyped these pairings around a number of different measures, primarily around growth and neurocognitive development, but also around a range of other different behaviours and parameters. We're lucky in GUSTO to have over 80% retention, so most of those children and mother pairs are still with us today, and the eldest child is around 8 years of age now. We have the 3 predominant ethnicities in Singapore: Chinese, Indians and Malays, which ethnically comprise around 40% of the world's population, and a reasonably good split between the genders as well. In the eating behaviour work that we do, we work with approximately half of that cohort, so we work with about 500 children, and most of the measures I'll present today are focused really around the 4.5-year-old and the 6-year-old time points, where we've looked in detail at the behaviours they exhibit around how they select calories, how they consume calories, and also then the parental influences. So we supplement our behavioural measures with parent report questionnaires of either child's appetitive traits or of parent feeding practices. And again, we're balanced for gender and ethnicity in relation to the wider cohort, but a big advantage of our cohort is we have very detailed body composition and anthropometry at each time point. So if we see a behavioural change in a child that is producing positive energy balance acutely within meals, we can also track that child's behaviour over time and also relate it to changes in body composition over time. And for the purposes of today, I'm going to focus on 4 of our primary questions in the GUSTO cohort. We're very interested in understanding a bit more around energy ends up on a child's plate and some of the factors that drive energy selection within children and also their parents' influence. We're also very interested in the behaviours exhibited during the meal in terms of eating rate and microstructural patterns of eating, how this differs within children and how it promotes or doesn't promote greater energy intakes. And Prof. J has already highlighted the role of viscosity, for example, in energy intake. At 4.5 and 6, we have different approaches to looking at energy intake and microstructure of eating. Beyond main meals, then, we're also interested in how food responsive children are and how this manifests as eating in the absence of hunger or calorie intake outside of main meals. And then, of course, at this age, the parent exerts a huge influence in terms of how they interact with the child and how they provision food for the child at mealtime. So we'll look a little at that and then discuss some opportunities for using these insights to improve how we tackle energy intake within children more generally. So if we start with energy selection at the child level, in recent years there have been new understanding in terms of how adults select energy using techniques like measuring expectations of fullness and satiety and relating them to calorie selection. And we've done some work on this ourselves in adults. But to date, actually, very little is really known about how children differentiate between foods in the environment, the role liking plays in that, but also how calories are selected and the quantity of calories specifically, and how this is related to the child's beliefs around the food. So to address this question, about 2 years ago, one of the researchers in our group, Dr. Kerry McCrickard, has developed a new tool using a story-based approach where if you take a character, Teddy the bear, and we ask a series of questions through Teddy to ask the child to express their hunger and fullness feelings at that time. And from this, then we can proceed to ask further questions around the child's beliefs around the filling properties of certain foods, their familiarity or liking for certain foods, and ultimately we ask the child a series of questions around how much of individual food items they'd like to choose for lunch today. So using this approach, we can engage the child in some questions about sensations that are often quite abstract. Hunger and fullness isn't always necessarily the first thing on a child's mind. But we can also tap into their learned associations between certain foods, their liking for those foods, and indeed their beliefs around fullness for those foods, and understand how those things interact to inform portion selection decisions at the child level. And we use a computer-based task where we've shot a range of images across a wide range of calorie differences for a wide range of foods. And simply using the arrow keys on the computer, the child can move between images and select their ideal portion for a wide range of different meals. Using this approach, we've been able to establish that children do, in fact, factor a number of things into their portion decisions when they're selecting food. Yes, it's true, children do tend to select larger portions of the foods they like, but they also account for fullness expectations as well. So they'll pick smaller portions of foods regarded as very filling and larger portions of foods that are regarded as not as filling. And interestingly, we followed the computer-based task with the child with an actual ad libitum meal where one of the 8 foods from the computer task was served to the child, and they were just told to self-select the amount of food they wanted to eat and then to consume in their normal way. And what we find is that the computer-based measurements have some external validity in that they predict significantly the amount of food a child would serve for themselves in a lunchtime meal. And so children are differentiating between foods, selecting their portion, and then the amount of food that the child selects for themselves is the strongest predictor of the amount of energy that they will consume during that lunchtime meal. Interestingly as well, children who select larger portions of food on a computer tend to select larger portions of a food in the actual buffet itself and in the ad libitum meal, and tend to consume more food overall. So portion selection at the child level is also driving calorie intake up. And if we can understand more importantly the interplay between expectations of fullness and liking and how they inform portion decision, we have an opportunity to think about how portion size can be used to moderate calorie intake within meals. Once the food is selected and on the plate, it's likely to be consumed. So the point to control energy intake is not going to be spontaneously necessarily within the meal. It's likely at the point of calorie selection. But we followed those children into the meal as well, and we have an opportunity to really explore the eating behaviors that they exhibit during the meal, using an approach based on behavioral coding analysis. And so what we've done is we have ad libitum food intake measured energy intakes at 4.5 and at 6 years of age. Children at 4.5 consumed energy from a buffet, and at 6 they were just given a meal of fried rice. And in both cases, they could self-select the energy they wanted to consume, and they could eat until comfortably full, and they were given adequate time to consume the energy. What you're seeing here on the video then is the closed-circuit TV of the child eating during the meal. And we see this is work from our team from iThing Go, who's now at this stage coded well over 1,000 meals for the GUSTO children at these different time points. And using the video, we can actually extract objective measures around the meal itself. So we can actually measure the bite, the number of chews taken for that bite and the swallow, and the time that that food spends in mouth. And if we do this across every mouthful of every bite of food that every child takes, we can then look at their energy intakes, but we can also look at the processing parameters around food intake that influenced that energy intake. And as Prof. J has highlighted earlier, oral processing plays an important role in moderating the rate of transition of calories from the plate to being in the stomach. We can also derive a series of measures from this, like eating rate, but also average bite size, chews per bite, chews per gram, and oral exposure time, and compare children head-to-head for those that consume a lot, those that consume much less, for the kind of oral processing parameters that they naturally exhibit during meals. And that's exactly what we've done. One of the researchers in our group, Dr. Anna Fogel, has spent some time looking at the relationship between eating rate and energy intake. And what we find is there's a linear relationship between the rate at which a child is eating and the amount of food they eat. If you eat faster, you will eat significantly more energy within a lunchtime meal, and this is data from the 4.5-year-old time point. Now, children within this task were free to eat for as short or for as long as they liked. If they wanted to eat for 5 minutes, they could eat for 5 minutes. If they wanted to eat for 20 minutes, they could eat for 20 minutes within the lunchtime period. So we reanalyzed that data based on the quartile of how long they ate for, and we see that within each quartile, eating rate is still a positive predictor of energy intake, but the children who eat the fastest and for the longest are eating significantly more energy than the children who are eating for less time. And this is again with no a priori instruction. Children were just told, we controlled for need states, so they just arrived at equal levels of hunger and fullness and just told to eat in their normal way and eat until comfortably full. And just to give you a visual example of this, we've split the children into a faster and a slower group using just a course median split. And what we find is that in the faster group, children on average eat about 75% more energy within the lunchtime meal, based purely on the behaviors they're expressing in that meal. And this is just one video example of one of the children from the slower group. And you can see she's eating at a normal pace. And then there's a video example of a child who's eating at a much faster pace and in the faster group. And so again, these are just natural behaviors from the child, and we don't know, of course, why they're eating faster or slower necessarily, but there's clearly an underlying drive to eat that's not captured by appetite alone. There's something else driving eating behavior. And eating faster and eating more within a single meal is interesting, but it's not important unless we can see whether it seems to impact body composition. So we've looked at that as well, and we've simply, using the same course median split of faster versus slower eaters, we've been able to associate that with their body composition. And we see a positive relationship between the rate of eating and BMI Z-score. Children who eat faster tend to have higher BMI Z-scores. But importantly, at this age as well, we also see a partitioning in relation to adiposity, and this is what's particularly troubling. Children who are eating faster were higher for adiposity across all skin fold measures and estimates of adiposity, including, in this case, we've plotted waist circumference. And we also were lucky enough in GUSTO to have 160 of the children or so had been through an MRI, abdominal MRI scan, where we can actually see the deposition of adipose tissue, and we see that children who eat faster have higher subcutaneous adipose tissue as well. And we know that this increases your capacity to gain weight in later life as well if you're laying down larger amounts of fat mass at this early stage in childhood. We follow these children, of course, to the next ad-libitum meal at 6, where they were served a completely different meal and asked again just to eat until you're comfortably full and eat in your normal way. And again, we see a positive relationship across all of the different weight classes, and children who are eating faster tend to consume significantly more energy. But in addition to that, we also could see that we could predict the eating rate. The children who were eating faster at 4.5 were much the same children who were eating faster at 6. So you were more likely, or more significantly more likely, to be a faster eater at 6 if you were already a faster eater at 4.5. And to the extent that we could take your eating rate at 4.5 and use it to predict your energy intake at 6 with again, a significant prediction. So this is a stable trait, and it seems to be predictive of energy intake, and so it's also, of course, a potential target for intervention. Now, with the behavioural coding analysis that we've run, it's possible to tap right into the eating behaviours that are expressed by the child within meals. We can start to quantify how children are eating faster, not just if they're eating faster or not. And using this approach, we've been able to establish that larger bite sizes that are chewed less per bite or per gram, and which transition the oral cavity at a faster rate, so they pass through at a faster rate, are what are facilitating faster eating rates, not just at 4.5, but also at 6. So even using completely different foods, these microstructural patterns of eating are driving intake up independently. And so we've studied this quite a lot in adults as well, and we've looked at things like the mouth-oral process model to understand the relationship between food structure and lubrication, and how that can also help to facilitate faster eating rates. The interesting thing about this, I suppose, is that using the knowledge we know now about bite size or chews per gram, we can ask ourselves what textural parameters we could potentially use to change eating rate, because of course we eat in response to the textures that we serve on our plates, and I'll give you an example of that later. In adults, we also know that this behavior is incredibly automatic and consistent, and in a paper we published last year, we looked at the consistency of eating rates across 4 experiments. And in that, we gave groups of people the same meal for 4 consecutive weeks and tracked their eating rate and intake across those 4 consecutive weeks. And not only were people very consistent within themselves in terms of how quickly or slowly they ate the same meal across those time points, we could predict how much energy somebody would consume on week 4 by the rate at which they ate that meal in week 1. So it's a very robust relationship. So we've highlighted 2 elements of child eating behavior that drive intake up: faster eating rates and increased portion size. And we have, of course, these are not unrelated, they're in the same children. So we wanted to look at the relative contribution, and you can see that, relatively speaking, in both faster eating rates and portion size are strong independent predictors of the energy that will be consumed by these children at 6 years of age. But they also interact. It isn't the case that they're completely independent. And what we see when we plot this is that not all faster eaters are going to eat necessarily more energy. Some faster eaters are controlling their energy intake by selecting smaller portions of food. The children that consume the most energy are the ones that eat the fastest and have a large portion of food, meaning that they are considerably faster and larger portions from the beginning of a meal. And this is also quite important because it speaks to the idea of where you'd intervene. If you try to intervene with a fast eater but don't consider portion selection, they'll probably manage to find a way around it. So this is a lot of information to gather, so I'll quickly give a quick set of take-home messages to capture the main findings from this first section. We've demonstrated from our data in GUSTO that children that select larger portions select more energy, children that eat faster eat more energy, but children who select larger portions eat faster and eat for longer eat the most energy. We see strong positive relationships between eating rate and body composition and prospective body composition. Your eating rate at 4.5 predicts your BMI and your adiposity at 6 in terms of differences. We start to profile these children at 4.5. Of course, we believe that these behaviours are stable and present from an earlier age because they're stable when we come across these children. And so the question is, when do these behaviours emerge, and why is there differences between children? So we've looked at the main meal in terms of portion selection and in terms of eating rate, but what about energy intake outside of main meals? And one way to look at this is to think about eating in the absence of hunger as a measure of food responsivity. How do children react with food in their near environment when they're already fed to fullness? And we've looked at this in GUSTO at both 4.5 and at 6 years of age by bringing children back into the room after they've finished their lunch. In both cases, they've reported feeling full and they've eaten a considerable lunch. And about 15-20 minutes after that, they're brought into another room and given some colouring tasks. And from this then, after about 5 minutes, presented with snacks. And the experimenter says, I'm going to have to go to the next room and just to prepare the next set of tasks, but feel free to snack if you want, and I'll come back and collect you then. And so, of course, we observe the children during this period and watch who snacks and who doesn't, and also the quantity of snacks that they consume. And this is a good measure of food responsivity within the child. So children are not eating for homeostatic needs, they're eating for the fact that food is simply present. And it gives us an indication of food responsiveness as an appetitive trait or impulsivity around food when it's present. What we asked was, what's the change in energy intake overall if children are eating in the absence of hunger? And we find that cumulatively between the ad libitum meal and the snack event, children that eat in the absence of hunger consume more energy overall. And because we have this at the 2 time points, we can see that children who are eating in the absence of hunger at 4.5 are 3 times more likely to be eating in the absence of hunger at 6. So again, this seems to be a stable trait that drives energy intake up when food is in the near environment. But what's also interesting is even when food's not necessarily in the near environment, we see this pattern emerge as well. If you remember the Teddy the Bear portion selection task we had earlier, we went back and looked at the children who ate in the absence of hunger versus those that did not, and found that those children who are eating in the absence of hunger are consistently selecting larger portions of food across all of the portion selection tasks in this computer task, indicating that their food responsivity is manifesting far beyond just intake of palatable snacks in the near environment. It may also be involved in how they think about food, how they plan for meals, and how they adjust their intakes. We got very interested in this, and within GUSTO we're lucky that we have a very rich source of measures on the neurocognitive development side, one of which is a very nice trait measure of impulsivity control, or inhibition control rather. So we have the Cantab battery, and we can use the stop-start reaction time task to separate children and classify them as low or high in inhibition control. And this is a very robust measure, and it seems to be very good at discriminating these children into these 2 groups. What we find then is that children who are low in inhibition control tend to also to be the children who are eating in the absence of hunger. So we can relate their food-related behavior back to a trait within the child. But really interestingly, we see the children who are lower in inhibition control also tend to continuously select larger portions, whether it be at the meal or on a computer task. They're the ones who are eating faster and for longer. They eat in the absence of hunger and consume more energy over time. And so we see a convergence of these behaviors that we're observing in the near environment alongside traits like inhibition control, and there are likely to be others. So the take-home message from this section is just to highlight that outside of main meals, children exhibit behaviors that are linked to greater energy intakes. These seem to emerge early, and again, with the time points we've studied, these behaviors are consistent in the same children over time. Importantly, these food responsivity reactions are not occurring in isolation. Highly responsive children are also picking larger portions, eating them faster, and eating for longer. So there's a convergence of these behaviors. And one trait that we've identified in our work to date seems to be linking this to inhibition control, although there's likely to be other traits as well that are likely to drive this behavior too. So in terms of child eating behaviors, we can watch how they pick food, we can watch how they consume it, and we can watch their snacking behavior, but really parents exhibit a huge influence at this age in relation to how they interact with children and how they control the flow of food through to the child. And if we've been able to observe these behaviors consistently over time, the question, of course, is parents eat with their children every day of the week. Are they also aware of these differences in appetitive traits within the child? And if so, what's their reaction to those appetitive traits? So we've studied that by looking at parent perceptions of their child's appetitive traits using the child eating behavior questionnaire. And again, this was mentioned yesterday. This is the parent report questionnaire that categorizes children's appetitive traits across 4 approach and 4 food avoidance behaviors. So looking at specifically parents' answers to questions like whether my child is always hungry or my child can comfortably eat beyond fullness, for example. And from this, we can then start to classify children who have high and low food approach or food avoidance behaviors, and then relate that to energy intake and body composition over time. And from this approach, we've been able to show that the children that we've profiled are those that are high in food responsiveness and high in enjoyment of food, but low in slowness of eating, so they're higher in eating rate, and low in satiety responsiveness, so not so sensitive to feedback at the end of the meal. These children tend to be the ones who have the highest energy intakes and have body compositions, as highlighted earlier, higher BMI Z scores, higher adiposity rates. But from a behavioural point of view, what we find very interesting is that when we do run a mediation analysis, we show that eating rate is mediating the relationship between the child's appetitive traits and greater energy intakes. That is to say that you can have a high appetitive trait for one trait like food enjoyment or food responsiveness, but if you're not eating faster, you're not necessarily gaining weight at the same rate as somebody who is. So it's also interesting that these behaviours that we've observed are similarly the behaviours that parents are observing when they're diagnosing or classifying their child as being very hungry or high in food enjoyment. So these stable behaviours are what's informing parents' awareness of their child's appetitive traits, and of course also informing the reaction to those traits. And when we looked at that, we could see an overlap then in terms of parental feeding practices and child eating behaviours, and sort of a bidirectional relationship. Parents of children who are eating at a faster rate were much more likely to prompt the child or to interact with the child during the meal, whether it be to speak to them or to encourage them to slow or encourage them to restrict their intakes. And interestingly, this obesogenic eating style that we've classified, this large bites, faster chews per bite, and faster eating rate and eating for longer, was prevalent in both boys and girls, but girls were much more likely to be prompted for this behaviour. So mothers were much more likely to intervene and prompt girls to slow down and restrict their intake than they were for boys. And because we have these measures at 4.5 and at 6, what's interesting is we can follow the children to the next time point and see whether or not there's an interaction there. And children who experienced the most prompts at the 4.5-year-old time point were still the children who were eating faster at the 6-year-old time point. If anything, these children sped up at a faster rate than children who were not prompted. So the prompting approach to reducing eating rate seems to be wholly ineffective, at least in the children that we've been profiling. Another way in which parents can influence the energy that a child consumes within a meal is in the portioning or the selection of food and the portioning of food for their child. And we've written about this in the past. A lot of parents report just knowing how much food to give their child. And we wanted to explore this in a little bit more detail and try to understand what are the factors that inform a parent's portion decision for their child in relation to the foods on offer and their child's need state. So using another computer-based approach, we could start to ask a series of questions to the parent around their child's preference for certain foods and their own preference for certain foods. We can also ask the parent to select a portion of food for their child for lunch across a range of different foods. So we can say, how much of this food would you choose for your child for lunch today? We can also ask the parent a series of questions around their own portion size beliefs and their own expectations of fullness. So which foods do you believe to be more or less filling? Using the same kind of computer-based approach I showed you earlier. What's interesting about this is that the strongest predictors of energy intake from a parent's point of view are not necessarily the child's hunger and need state. Parents are much more likely to give the child a larger portion if they thought the child might like that food. And parents also gave significantly larger portions of food to their child that they themselves selected in large portions. So a parent's belief around how much of a certain food they wanted to eat was what they also chose for their child. Similarly, if the parent had an increased liking for food, they tended to give more of that food to their child, and foods that were expected to be less filling were selected in larger portions. One of the weakest predictors of the ideal portion size that was selected for a child was in fact the hunger and fullness need state of the child. So what we find is that mothers' portion judgments that they are selecting for the foods they're selecting for their children can be biased by factors outside of the child's need state or energy requirements and biased by their own perceptions of food or what their child might like to eat. So to capture some of this, I suppose what we've been able to show is that the behaviours we've observed, parents are also aware of these behaviours and they observe them through the appetitive traits that they've rated on CEBQ. Such as things like eating faster, eating for longer, eating with larger bite sizes. And the reaction to this, at least in the children we've profiled, is that oftentimes parents react by restricting the child's behaviour around meals or encouraging them to slow down and interacting. And this seems, at least from the data we have, wholly ineffective in the same sense because children who were being prompted the most were also the children who tended to continue to eat at a faster rate. If anything, they started to speed up. I haven't got it on the slide, but parents also strongly influence energy selection at the child level based on the portions they choose for their children. And oftentimes these are based on factors wholly unrelated to the child. They're based on the parents' own perceptions of food, their own likes, and what they think the child might like to eat and eat more of. This relationship then, from our understanding of it, seems to be bi-directional, that parents' feeding practices are influencing the behaviours exhibited by the child, and the child's behaviours in turn are being influenced by the parents' feeding practices. And so we heard yesterday a lot of recommendations on how to interact and influence child behaviours, but clearly this type of approach at least is illustrating that some of these interactions can, if anything, exacerbate underlying risk from certain appetitive traits. If you're highly food responsive and you eat very quickly and you're being prompted by your parent, it could lead to increased difficulties. Similarly, if you try to intervene on one of these elements, if I think about trying to change a child's eating rate and not account for the potential impact of parental feeding practices, I'm unlikely to be successful long term, because any intervention on a child is not going to necessarily translate to the wider environment within which they eat. So we've looked a little bit about all of these different parameters that are all significantly influencing portion selection and energy intake acutely within meals, and we've been able to show that all of these parameters in one way or another lead to greater energy intakes and a more rapid increase in BMI Z-score and a more rapid increase in adiposity. So what's the opportunity for us then? What can we think about doing with these insights in terms of approaching changing behaviours in a way that could be somehow actionable? So we started by talking about the risk factors from the first 1,000 days that Izzadeen Aris has recently reported. An increased prevalence of risk leads to increased cumulative chance of having a higher BMI Z-score at 4. Our eating behaviours that we've identified all increase energy intake, higher portion selection, faster eating rate, increased eating in the absence of hunger, eating for longer, being prompted by your parent or being interacted with by your parent during a meal, and similarly parental portion selection in terms of calorie allocation to the child. We also see these are not independent factors, they all interact around meal times, so there's an overlap between things like portion selection and indeed eating rate. And so we wanted to start asking some questions, and this is just some preliminary analysis of this. Is there an overlap between the behavioural risk we're observing in our children and the risk factors identified in the first 1,000 days for the same children? And we see from Izzadeen's analyses that greater risk factor scores lead to an increase of BMI Z-score in children at 4 years of age. So increased number of risk factors, increased BMI Z-score. We've begun some preliminary analysis on a smaller group of children, and what we find again is that the children who are exhibiting the highest number of risk factors from the first 1,000 days are also the children who are eating at the fastest rate. And we haven't looked further, but ideally we'll look at the other behaviours and see whether or not these are also the children more susceptible to eat in the absence of hunger or select larger portion sizes or exhibit these appetitive traits that acutely are shown to exhibit greater intakes within meals. This is important for a number of reasons. One of them is because we can't treat all of these behavioural risk factors as equal. We should weight these risk factors based on the contribution they make to acute energy intake. So certain things, like large portions, for example, that are eaten very quickly will have much more of an influence on energy intake and can really drive positive energy balance. Similarly, larger portions are less of a risk if you're using lower energy dense foods. And so we have to think of the broader matrix of different risks, how they combine and overlap within children and then subsequently relate to greater energy intakes. And this in turn is not just important in terms of identifying the children themselves, but also in terms of the appropriate strategy to tackle a child's behaviour. An intervention at the child level might not influence parental feeding practices that are driving these aberrant feeding behaviours. And similarly, it might be easier to think about an integrated approach that might be much more effective. So we're in the process of thinking about developing eating behaviour risk scores that overlap with the risk scores from the first 1,000 days. And the goal of this would be to develop measures that can target interventions in a way that improve our ability to discriminate children and make sure these interventions are targeted to the behaviours that are exhibited that are promoting energy balance over time. In addition, we can think about changes in the child's environment. We talked yesterday about overt restriction being a troublesome area, but perhaps covert restriction in terms of limiting the actual availability of these kinds of foods in the near environment might also help in terms of reducing the risk of overconsumption from highly food responsive children. Parental influences are very, very strong at this age. We know we hear much more about the ones that are not to do, but there are also a range of very important parental influences that we should be doing in terms of structured meal times and modelling, for example. And these can also be helped to moderate the behaviours of the child during meals. The trait that stood out from our analysis to date has been low inhibition control, which seems to be an area where a lot of different overlapping aberrant behaviours converge. One area of interest is not just to intervene on the food environment of the parent, but also to think about strategies to change the child's ability to self-regulate their energy intake. And in fact, many of the parental feeding influences are really about trying to give the child an opportunity to establish feelings of hunger and fullness and establish how much food they need to abate those feelings. And so there are a range of new strategies being developed, from app-based strategies to more advanced strategies looking at how to encourage self-regulation. One of them, of course, is just to discuss hunger and fullness at the start and end of different meals, and have children relate what they've eaten back to the change in that sensation at the end of a meal. One area that I'll finish on is an area we've done a lot of work on in adults, and we haven't done any work on it yet in children, but it's about using the foods that we serve and the sensory properties of those foods to change the behaviours exhibited by children during meal times. So can we use simple changes to food texture, for example, to do more or less the opposite of what Prof. Jaya was discussing? Instead of trying to increase or decrease the viscosity to encourage complementary food intake, we're looking at ways in which we can put the brakes on energy intake within a meal, but in a way that's ecologically valid and will be acceptable. So just to give one example of one of the studies we've run in this area, this is work from last year where we took a standard breakfast in Singapore is our rice congee, our chicken rice congee, which is a porridge made out of rice, and you can change the formulation quite easily by using a different mixture of rice and blended rice and water, and have energy equivalent versions of the same rice porridge, and have one that can be eaten very, very quickly or one that can be eaten very slowly. And so we validate this and show that our thick one can be eaten about 74 grams a minute, whereas our thin one, which is a little bit easier to eat, is about 140 grams a minute. So quite a big difference in eating rate. What we wanted to know was if we served this to a group of adults ad libitum, and if we manipulated other parameters around that meal, its energy density and the portion with which we serve it, do we get an intake change at the meal? And does it change amount consumed to fullness and the fullness experienced after a meal? And what we've found is that when we serve the slower version of this rice, simply by making it a little bit thicker, the least energy is consumed when we have a low energy version of this thicker rice, rice porridge, sorry. And I should emphasize that in all cases, these rice porridges were equally liked by the participants. There was no difference in liking, and no difference in post-meal fullness and hunger. And similarly, when we serve a smaller portion version of this thicker rice porridge, we see that, again, the least energy consumed within the lunchtime or the breakfast meal was for the small portion of the rice porridge as well. And we've done this now in about 3 or 4 different ad libitum trials, and each time we see that using simple changes to texture, we can affect about a 10 or 15% reduction in ad libitum energy intake within a meal, with no change in liking and no change in post-meal fullness. So I think there's an opportunity here to play on food structure and how foods are processed and presented to children in a way that can moderate not just the nutrient content of those foods, but more importantly, the eating behaviours that they exhibit around foods, so that we can slowly nudge them back towards healthier eating styles that don't promote greater energy intakes acutely. So to conclude, we've covered a lot in terms of the eating behaviours we've observed in the GUSTO cohort. I hope I've been able to demonstrate that eating behaviours play an incredibly important role in terms of moderating the flow of energy, and that there are quite large differences in the behaviours exhibited by children, even just natural behaviours observed within a normal meal. And these can influence intake within and across meals and are related to differences in body composition. So things like eating rate, portion size, and impulsivity or food responsiveness around foods seems to drive energy intake up. One trait that seems to unite a lot of these is this inhibition control trait, but we believe there's probably others as well that we need to start to think about. And each of these can help us to understand the kinds of behaviours that are driving positive energy balance over time. Similarly, if you might have an underlying appetitive trait risk, that can be exacerbated further by the parental feeding practices that are used during meals. So many of the eating behaviours that we've identified at 4.5 and at 6 are quite stable. The same children are exhibiting these behaviours meal to meal, and even though we've changed the foods and the parameters around the meals, it's still the same children who are doing the same thing time and time again. That's a problem because it means that every meal they eat, they're exhibiting this intake increase because of the behaviours. It's also a massive opportunity, of course, because if we can affect a successful change in those behaviours, we get a net decrease in energy intake meal to meal in a way that could be sustainable. So that's something that we're very interested to think about. And if we do think about that, we shouldn't intervene exclusively just on the food served and its parameters, but also a range of parameters around meals in terms of instructions to parents on how best to deal with a faster eating child, or indeed in terms of the food environment more generally. And so I think a multi-stratum approach to tackling these issues is really central to any successful intervention. And with that, I have to thank the team behind all of this work back at our Clinical Nutrition Research Centre in Singapore, so specifically Dr. Dekaria McCrickard, Dr. Anna Fogel and Aiting Go, and also to our wider GUSTO 8.2 team and to the GUSTO cohort, and to you for your attention. So thank you very much.
Okay, thank you, Dr. Forde, for enlightening us on the obesogenic eating style that promotes greater adiposity, specifically on the concept of eating rate, eating in the absence, the EAH, and of course, parental influence. So with that, maybe the floor is now open to questions. Could you please state your name and your country?
Hi, I'm Reagan Bailey from the U.S. Wonderful talk. I'm really not familiar with this whole area, so this might be a very naive question. But when you described a child's rate of eating, you said it was a natural phenomenon. Is that known, or could it be a learned phenomenon by watching other people, or have you looked at that with the mothers in your cohort?
Well, that's a great question, and actually, well, more than likely it is a learned phenomenon in the sense that, as pointed out by Dr. Niklas yesterday, we are born with certain innate taste or smell preferences, mostly taste, but everything else is learned. And we believe that certainly the trait of eating faster is lots of influences, some of which it's been shown to be a heritable trait, for example, in the twin studies in Gemini by Claire Llewellyn. It's also the case that it's likely a product of your food environment, and of course the eating behavior of your family members and around meal times. And if you think about the first 24 months of life and how much happens from a sensory point of view, the average child's palate length doubles, it fills with teeth, the muscle in the middle of your mouth that guides food back to the molars for crushing, you have to learn all of these things. And so all of this is very much strongly learned, and speaks to the idea of the importance of textures of complementary foods and aligning those with the emergence of dentition to process those foods. Your central pattern generator becomes stable by 24 months, and so even the act of chewing is stabilized at that point too. And certainly that's an area that requires much further research.
Yes, ma'am.
Thank you, Ciaran, for a really interesting talk. I was puzzled by the first part of your talk regarding energy selection in children, and I really was wondering whether hunger perception in children would influence energy selection, because you showed you measure hunger with a teddy bear scale, and so is it a predictor of energy selection?
It's a great question. Of course, in our controlled test environment, the hunger state of the 500 or so children that completed that buffet was somewhat controlled. They were given instructions on when to and not to eat before that specific task, and that certainly probably had a role to play in downplaying the role of hunger. But certainly children who were hungry at that point did select larger portions, and children who were fuller selected smaller portions. But again, that comparison was probably attenuated somewhat by the test as well to control for need state.
I'm just wondering, because in one of our studies we measured the hunger at the beginning of a meal, and it was not associated with energy intake at the meal.
Right.
So I think when you mentioned in your perspective that it would be interesting to prompt talking about hunger and fullness, maybe it's a way forward, but I think we need much more information on how this could be a way forward to really help in energy intake control.
No, I think that's a very fair point, and in fact it's often an area that's overlooked because we are challenged by the cognitive abilities of children to articulate these sensations in the first place. So how you ask about these questions has a huge influence in terms of how you get information back. But we're also interested in even just the relative change with regards to Teddy the Bear hunger scales, for example, and whether they change over the course of a meal. Are they responding accurately? And that's the case, yeah.
Yes, please.
Thanks, Ciaran, for this great presentation. I have a question, especially related to the first part of your presentation. How would you translate your findings into a real family situation where the family eats together? There are a lot of disturbing factors, and there's especially a very limited time of eating. It's stressful time very often, don't have time for eating. Did you look at parental, especially mothers, eating rate and how that actually has an influence on the child? And did you also see a difference between the eating rate of a healthy food versus an unhealthy food? And knowing that, would you then advise and giving far more emphasis on the base education of taking time for eating and also again starting with the parents?
Yeah, I think that you raise several important points. I mean, certainly in terms of time-pressed, stressful meal times, it might not be the best place to start in terms of addressing a problem like faster eating rates. And so to some of the comments made yesterday around structured meal times and structured parents sitting at the meal as well, I think that's certainly very important. We haven't measured the eating rate of the mothers in this trial, and the mothers didn't eat with the children in the trial either, so the child was eating alone. It's certainly something we'd be interested in, and the suggestion would be that parents possibly also exhibit many of these behaviours themselves. In terms of where to intervene, I think in the first instance creating an environment that is not rushed and stressed, I suppose, would be a first point. But also our focus, at least in our group, has been primarily on looking at simple ways in which you can nudge these behaviours to slower eating rates by playing on components of the meal. So looking at simple things like using natural variations in the textures of food that are equally liked, that are similarly liked hedonically by the child, but that have a natural impact on the average bite size, the chews per bite, and the time it takes to form a swallowable bolus. And this in turn seems to naturally slow down, at least in the adult population, eating rates to affect a change in energy consumed to fullness.
And did you see a difference in the eating rate between a healthy and an unhealthy meal?
Sorry, yeah, so that's a good question. Again, we didn't have, specifically didn't have healthy or unhealthy foods in the trial per se. We just had familiar foods, so foods that we'd identified from a food frequency questionnaire as common at this age. But of course, in our adult work, we've done a lot of work with just on profiling the eating rate of different foods in Switzerland, in the UK, in the Netherlands, and in Singapore. And we don't find a very strong relationship between the hedonic appeal of a food and the rate at which it's eaten. And that may be for a number of reasons. But we don't see that necessarily unhealthy or likable or highly palatable foods are eaten at a faster rate, at least not consistently, across all of these studies. So it remains to be seen whether that actually is driving the rate of eating.
Okay, Dr. Salvador.
Hi. I just loved your presentation. It was fantastic, all the work you're doing. And I was wondering if in terms of, for clinicians, there should be a way to translate these risk factors to protective behaviors. I mean, if you actually, do the numbers backwards, you will find protective behaviors. Could you identify any of those in the risk factors as potential protective behaviors?
I mean, I think it's as a multifactorial problem, it's going to have to require a multifactorial approach. I think for a clinician, you often see children of this nature when they present for treatment, and oftentimes because they maybe are 4 years of age, but with the weaning age of a 2-year-old. And that may be a product of the textures they've experienced in their environment. And then they're in they're seeing a speech and language therapist, for example. And that's really treatment rather than prevention. From protective behaviors point of view, obviously, a lot of what we've heard in the last day or so has been around mealtimes and family structure and parental feeding practices. From a food point of view, learning to eat in the appropriate way and in the appropriate context is a protective behavior. Identifying hunger and fullness as a potential driver of energy intake, and not to eat necessarily just to eat because food is there, is a protective behavior in and of itself. So in training the kind of behaviors that, if you identify appetite traits that are driving energy intake up, well then each of these manifests as a behavior. The appetitive trait itself doesn't give you positive energy balance. It has to occur around things like portion selection, around things like giving adequate time to meal times, and in terms of training appropriate eating rates with the right kinds of textures. And from that point of view, there's a range of potential ways you could apply that then to encourage these behaviours to be the right ones from the beginning, instead of trying to apply a corrective action at the end.
Are there other questions? Yes.
Thank you very much for a really interesting talk. I just wanted to know if you found any differences, ethnic differences, between inhibitory control and eating styles.
Yeah, it's a good question. We looked, of course, we're very lucky to have a multi-ethnic cohort, and for all of our analyses, for all of these behaviours, we've looked, of course, at the ethnic differences, and in some cases there's some small ethnic differences. For example, in the 4.5-year-old time point, there was emerging differences between Indians and Malays maybe eating slightly faster than Singaporean Chinese. But actually, when you control for this, it doesn't change the relationship at all. So even many of our analyses will control for gender, ethnicity, and BMI, and we still see this relationship. So it's not the case that there's one strong ethnic variation. That's not to say that there aren't ethnic differences, because of course in Singapore we have a very multicultural society and it's quite a unique environment. But if we were to rerun similar studies maybe in different parts of Asia, we might see subtle differences. And the differences could be partly due to the ethnicity or the culture of the family of the child, but also largely due to the textures of the food environment in those countries as well, I think, where you learn to eat and where you become a faster or a slower eater perhaps.
With regard to the ethnic differences, now you are looking at an Indian community in Singapore, which is essentially a transplanted community, which means that their entire culture has been modified. It's not going to be easy to translate that to an Indian community which is still in India. Their cultural practices, their environment is totally different. So whether you can translate this ethnic multi-ethnicity that you've got in Singapore, which is a stable environment, to an environment like ours. We are all from India, but we have got 3 totally different environments, totally different food practices. Though we are both from the same state, our food practices are different. So there is going to be a problem as far as trying to translate it into a multi-ethnicity. Number 2, when you talked about stable eating habits or eating rates, did you take into account the environment? For example, in my country, maybe at the age of 4, the child is being brought up by the parents who have to go to work. At the age of 6, they have gone abroad and it's now looked after by the grandmother, where the amount of pressure to eat fast is much lower. So there the eating rates will change. Similarly, if the school rate, the time at which the school starts maybe at 8 in one place and at 10 in another place. So if the pressure on the child to eat fast is higher when he has to go to school early.
Yeah, I think you raised some very interesting points. I think we're not seeing necessarily that pressure to eat or speed of eating is driven by the time constraints, for example. I think any change in environment has a net impact on the change in behaviour as well. I would agree with you that if it's a parent or a grandparent or a carer looking after the child, it's quite different in terms of the interaction. Nevertheless, these behaviours seem to be reasonably stable regardless of the food type we're serving or the meal context. Our children in the studies we've run are not time pressed, and so clearly if we follow this into, for example, the school environment in Singapore, we could look a little bit more closely at whether the time constraints of lunch breaks might influence eating rate. I think also at this age as well, 4.5, 6, children are also strongly influenced by their peers as well, and so you might have a slow eating child who happens to eat softly textured, fast consumed foods with a bunch of children who also eat very quickly, and that in turn may also change behaviours over time. So I would agree with you that environmental change at this age during this formative period can have a net impact on the behaviours exhibited.
Have you been able to look at the effect of these behavioral modifications on the outcome of the problem any time?
We haven't done any behavioural modifications on our children yet, certainly in terms of texture or guidance. And in the adult studies we've run to date, they've been acute studies. So we see net changes in 24-hour energy intake, but we haven't followed them for weeks on end. That would obviously be the next stage. I should point to some work that's been done in Europe, though, in relation to longer-term changes and retraining eating rates. Eating rates been identified as a potential risk factor for obesity for quite some time. And there's a reliance on using, for example, external devices to cue appropriate eating rate, and so to retrain the eating rate using a machine or a beep or a cue from the meal that slows you down. And there has been some success in relation to changing BMI, for example, over time. Although adherence to these protocols is quite difficult because you're asking to introduce instrumentation or cues to the meal that are not normally there. In one example from a paper from pediatric obesity about a year ago, and they used egg timers, and at the end of each bite you had to turn the egg timer over and you had to wait until this was finished before taking your next bite. I mean, people who adhered to that protocol certainly ate less, but whether it was because they changed their eating rate or just got tired of waiting for an egg timer to go through remains to be seen. And certainly it's not going to be a global solution to a problem like eating faster. We believe food is going to be the solution, food texture and food composition.
Okay, Dr. Mai.
Can I just ask here, and I really enjoyed your talk, as I think everyone else did. I don't know anything about this lower inhibition control, but it seems to me to be central to what you're discussing. And leaving aside food, how else does it manifest itself in childhood behavior? And as the child grows onwards, does it make them smarter, quicker? What are these children like?
Well, I should defer to the psychologist who can add to my answer, but in the measures we've taken, we're only primarily interested in food-related behaviours, but of course a lot of these children also tend to be more impulsive and so oftentimes have a shorter attention span, struggle to complete the Cantab tasks, so they're much more restless, and I believe it's also associated with things like ADHD, for example, as well in certain children, but I welcome any comment from some of the psychologists who want to contribute as well to that answer.
Well, inhibition control is a big thing these days in terms of looking not only in children but also in adults. What we know about inhibition control, it's a task that relates to frontal lobe performance, and the frontal lobes is something they don't develop fully until the age of 24 years old. So what we find in children, they're naturally less able to inhibit certain responses, so don't eat this cookie. It's much harder for a child to resist, but what we find is that children who are better resisting food cues or any other things, like don't press that button, their ability to self-regulate is improved across childhood, but also it predicts their ability to regulate at adult level. So what we can see here from the data is that children that are less good at controlling food intake at the younger ages are also likely to be adults who will be less likely to control food behavior, but also others' behaviors. They might be more susceptible to addiction, addictive behavior, and so on. Thank you.
I would just like to have the last question. It was said yesterday that infants have they are innate self-regulators. And therefore, if there is disruption of this inborn ability to self-regulate, then that causes some problems of food intake, specifically greater food intake. So is your eating in the absence of hunger the same as the higher score for dietary inhibition? Is it the same?
Well, I'll come to your first part of the question, which is about the innate ability to self-regulate. I think the data was shown yesterday. I think that also shows that children tend to lose that ability as they get a little bit older, and so start to rely on other cues. I think it's a very interesting question. At what point do factors in the near environment or in the experience of food and meal times do we start to lose that ability to self-regulate? And some people maintain it, and as we've heard, can be successful in terms of calorie intake and other things. But the change from a child who can self-regulate very well to someone who is much more susceptible to the potential of increased positive energy balance in the near environment, it remains something that we don't understand fully, I think, in terms of the factors that influence that. But certainly some of the behaviours we've identified, if you are a parent, for example, who is very keen to feed your child, you know nothing about energy density, and you're basing all of your child's portion decisions on your own opinion of a portion that would suit you, and you yourself are, for example, a plate cleaner, well then a range of external factors around the meal are driving the decision to feed that child that are not necessarily linked to their own ability to self-regulate. And if that happens over time, we would expect there will be a blunting of this self-regulation, and over time you become much more tolerant of these satiety feelings and the natural feedback mechanism we have to curtail an eating event. And so I think what we need to do is understand how all of these different factors interact to reduce that self-regulation, the innate self-regulation ability in young children.
Okay. Thank you very much, Doctor. Maybe just one last question. We still have 41 seconds.
41-second question.
Oh, we should give Ciaran some peace.
Somebody down here.
Yes,
Thank you for that lecture. I was just wondering, I was just curious, what were the food choices of the children who were offered the buffet spread in terms of energy density and the macronutrient breakdown? Thank you.
Thank you. That's a great question. So it's a question that comes up whether or not the differences in energy intake were driven by the differences in food selection by the children during that ad libitum meal. And we've looked at that and find that actually in the fast or slow, high and low eating energy intake groups, there's no significant difference in the foods that they chose within that meal. We've also gone further and looked at the eating rate specifically of the foods within the meal, and we see that with the exception of 2 foods, all of the other foods were eaten at much the same rate. And so the food selection, the choice, the macronutrient or energy density of those foods isn't actually driving the relationship. It's the innate ability of the child to eat at a faster rate and consume more food within the time period is what's driving that difference.
Okay, with that, let's end this session and give a round of applause to Dr. Forde.